All right, today we're going to do an architectural teardown of Vanguard Pay. This is a high-performance protocol that's really built for the coming wave of autonomous economies. So let's jump right in and see what makes this thing tick.
14,831. Now, just look at that number for a second. It's not just some random figure. It's a statement. It's a measure of performance, a benchmark for what this system is capable of. But what does it actually mean?
Well, that number, that's transactions. And this isn't a simulation. This is the live protocol throughput, captured right from the public mainnet. It's what the system is handling as we speak. So that's the what. For the rest of this explainer, we're going to unpack the how.
So how does Vanguard Pay even begin to achieve that kind of performance? Well, it all starts with its foundational structure, what's called the MCP pipeline. You can think of this as the core framework that makes everything else even possible.
So what is an MCP pipeline? At its heart, it's basically a highly structured peer-to-peer handshake. It's this dedicated programmatic path that connects an agent that wants something, a vault to secure the payment, and an endpoint that actually provides the service. It's like the dedicated highway system for autonomous value exchange.
And this visualizes those pipelines in action perfectly. Let's just trace that middle one for a second. You've got an autonomous AI agent, GPT-4o, and it needs to access a compute_cluster. The MCP pipeline orchestrates this whole thing as a direct flow, and it's all mediated by something called a TV vault. The key here is that it's not broadcasting a request to the whole network. No, it's a very specific, very secure handshake.
We can really boil this entire flow down into 3 clean steps. First, you've got agent initiation. An AI like GPT-4o says, I need a resource. Second, vault mediation. The vault steps in and acts as a high-speed digital escrow. And third, endpoint execution. The compute cluster delivers the service. Initiation, mediation, execution. That's the loop, and it's happening thousands of times every second.
But look, pure speed isn't enough to build a really sophisticated economy. You need intelligence, right? And that brings us to the protocol's economic engine, reputation-based discounting. This is where the system gets really smart about its pricing.
And this formula right here, this is that intelligence in action. See, the price isn't fixed, it's dynamic. It's calculated on the fly using this formula. The system actually looks at an agent's past behavior and mathematically rewards the good actors with better prices. It's a whole economic incentive system, and it's baked right into the protocol itself.
And if we look at the table, we can see exactly how this plays out. You have the base price, P sub B, which is just under 0.007 SOL. But the variable that changes everything is R, the reputation score. With a really high score, like 0.93, the formula spits out a final bid price, P sub F, that's almost half the original ask. The takeaway here is huge. In this economy, a good reputation isn't just a nice-to-have. It has real, tangible economic value.
Of course, all this speed and all this economic intelligence wouldn't mean a thing without an absolutely unbreakable layer of security. And this is where we zoom back in on that TWE vault. It's not just a mediator, it's the security linchpin for the entire architecture. You see, the TWE vault is the decentralized guarantor for every single transaction. It basically functions as a trustless escrow. It holds the funds securely, and it only releases them when the service is successfully completed. This is what allows any 2 agents, whether they're anonymous people or autonomous AIs, to do business with mathematical certainty. It completely removes the need for any pre-established trust.
Okay, so we have speed, we have intelligent economics, and we have decentralized security. The final piece of the architecture ties it all together, provable verification. I mean, how do we actually know any of this really happened? Well, that's where the immutable audit trail comes in.
And here it is. This is the proof. This is the TWE log, and it's recorded directly on the public blockchain, which makes it an on-chain record. It is a permanent public ledger of every single settlement. You can see the agents that kicked things off, like Gemini-1.5. But the really critical columns are event type, X402 settlement, and the final status, verified. This is an indelible, unchangeable receipt that proves the transaction happened exactly as claimed.
So there you have it. You've got high-throughput pipelines, reputation-driven pricing, trustless settlement, and a permanent audible trail. It's a complete, self-contained system. And that leaves us with a pretty big question to think about. When trust is mathematically guaranteed and everything is auditable, what becomes the next frontier for autonomous economies?